Hello, everyone, and welcome to the DOM calculator review. So Tiffany was kind enough to donate some code that we are going to lovingly tear apart and figure out how we can make it better. All right, let's see how far into this we got. So if I look at this, all in the root directory, if I run a server here, if I install a server and then run a server. All right, so we see the DOM calculator here. Buttons do some stuff. Hey! Well done. Okay, can I multiply? Hey! Not bloody bad, Tiffany. Pretty good. That works. All right, let's take a look at the, let's see, did we do division? Divided by 2. Okay, very nice. That is a working DOM calculator. Let's take a look at the code. Nice and concise also. Very good. So notice a couple of you mentioning that you get this to work with script source defer, not with DOM content loaded. You should know how to do both of them. They do the exact same thing though. So throwing a defer in here is the same as adding an event listener to the document for content loaded, and then running a function, and then just doing that. Exact same thing. Questions about that much?
Did you just throw the curly brace at the end of everything? Was that what you did there?
Yeah, I just pasted it in the middle of it.
Cool.
Is it the same thing because defer source doesn't load everything until the JavaScript?
Okay. Until what?
Until all of the HTML loads to the DOM?
Until the DOM content is loaded, you say?
Yeah, that.
Yes. So let's remember like what's actually happening under the hood here. Can I do it this way? So we've got our front end server here. This is different than like our API server. This is like what light server, HTTP server, anything like that. It's also a server. It's a little bit different than the one that helps us talk to our database. So we don't have any of that in this problem, but we still have this front end server. And we make requests for HTML files. So every time you load up a page like this, it's making an HTTP request for a file called index.html at this address. So it goes, yo, you have a file called index.html by chance? And it goes, why, yes, I do. Here it is. And then, like, HTML is instructions on how to build the DOM. It's not the DOM itself. So then it DOMifies, that's a made-up word. It DOMifies that HTML, loads it all in, builds out that tree. So it's taking this HTML string we have, it's breaking it down into a DOM tree. After that, the HTML goes away. It's pooped out. It doesn't have any use anymore once it's the DOM. But the DOM is what we can interact with JavaScript. We can make new DOM elements. We can add event listeners to DOM elements. We can do all these kinds of things. So this event listener is saying, hey, document. And document's the top of this. That's the entire page. We're adding an event listener is like, whenever you finished turning that HTML into the DOM, do all this. And that's important because we have to do things like get elements out of the DOM. Can't do that if they don't exist yet. That's why we gotta wait. Script source defer, exact same thing. Ask me some questions about that.
Would you want to use that over defer if you're like, I don't know, you have events that need to start exactly when it starts loading, like a counter, for example, that would start like right when the DOM starts loaded?
No, you would use it if you're using an old browser that doesn't support defer yet.
Oh.
You might also have scripts that don't depend on the DOM being loaded, like ad tracking stuff. Usually don't need the DOM for that. It's a split-second difference between like when the HTML starts parsing to when the DOM is finished loading, but maybe a split second is what you need.
Is one faster than the other?
Nope, they are the exact same thing. Other questions? Cool. All right, so let's start tearing this apart a little bit. I like this. I don't like that we're mixing and matching query selector stuff with get element by ID. Just use query selector. I don't think there's a whole lot of good reasons to not use query selector for everything. Cool. We're mixing and matching single and double quotes. It doesn't matter which one you use, but stay consistent on it. So if we're using double quotes on those, let's do it with these two. Same thing here. Little stuff like that is, you can say on your resume or your cover letter or something is like, I have a lot of attention to detail. But then if somebody sees that, they go, no, you don't. So little things like that are how you communicate your attention to detail. And the best way to do that is to not have to remember it at all. If you have like a linting plugin for your text editor, it'll fix all that stuff for you. A lot easier than trying to remember it every time. Get a couple more over here. Get rid of that. All right, so let's look at how Tiffany approached this. So the buttons div, which is every span, only spans, you might say. Oh, pow! Everything with a span tag on it. Cool, so we had a single event listener for that. Anytime there's a click that happens on one of those, we want to yank out its text content. We want to append it to the screen. And if it's a C, we want to clear. And if it's an equals, we want to calculate. Cool, not bad. So what is clearing? Wiping out the inner HTML, okay? What is calculating? Oh, this is pretty clever. So we grab all the content. I'm not sure that slice was necessary. I don't think that's actually doing anything. But Tiffany, was there a reason that you did that slice in particular?
Sorry, Paige and I were working on this together. I think that,
It got rid of the equal sign.
yeah, that's,
Ah, I see. Because, check this out. You appended the equals to the screen, and then you ran this, which is why you had to do that. Interesting. And really, technically, the same thing is happening with the C, except you immediately get rid of everything. All right, we'll talk about that in a sec. You did an outstanding chained regex replacement here. That's nice. I would have formatted this like this. I think it makes the chain a little bit more explicit. It's easier to read, but it's good. All right, and then you eval this string where you replace these things. Clear the screen. You clear the screen and then you rewrite the screen. Okay. Overall, this is a terse little bit of code. Ask some questions about it. I'm assuming like not everybody did it this way, so questions about alternatives we could have done, why Paige and Tiffany did this way in particular, trade-offs, that kind of stuff. Ask some questions.
So I took a pass at this, and I'll be honest, I bombed it. I understand everything up until line 28. What's the need to clear value there after you evaluate your output or get an output? Yeah.
Because they're doing this append. So let's say we have 1 plus 2, and then we hit equals. We're going to have 1 plus 2 equals 3. Or we can do 1 plus 2 equals, and then just get rid of that. But we have the 3, and now that all of that is gone, we can add the 3.
Got it. So it's like resetting your screen to show your output, your solution.
Exactly. Here, we can test it out. Check out what happens when we don't do that. 1 plus 2 equals 3.
Got it.
Versus if we don't append the result, and so we do those both at the same time, we get the 3.
Thank you.
Other questions? Great, like exactly what we're talking about. More questions about this approach?
I guess, how would you do this a long way without eval?
Great question. So there's a few different ways. I think probably the easiest one is to tokenize it. So what that means is if I have something like this, we want to split this into tokens. So it'd be the number 3, a plus sign, and then the number. And so then like that gets more complicated when we have things that are more than 1. So we don't want to split this up into 2, 5, 6, and 3, or maybe we do. But we want to split that up into 256, the plus symbol, and then the number 3. So like the general approach for something like that is you split this up into an array of these things. And to get the token 256, you go, all right, I have a 2. Is the next thing in this a number? Oh, it is? Cool. Then like add that to this. Cool. Is the next thing in that a number? Cool. Well, then add that to this. And then you could do things like, all right, starting from the right and working to the left, I want to multiply each of those numbers by like its place. It's like tens place. And so you can use like some base 10 math to generate the actual number. But ultimately, still, you're looking for tokens. This token, that token, and then this token. So let's say you have an array of those. You can go through the array and say, all right, this token's a number. The next token has to be an operator. So based on what the operator is, if it's a plus, I'm going to run my add function with that and then the thing after it in the array. And then I'm going to get rid of those things in the array and keep going. That's how you could do it by hand. Not super important. It's like, it's something you might come back to later in the program because it's super good interview practice to write something like that, but it doesn't have anything to do with the DOM. Other questions?
As one question is, you were talking about how we were appending like the C or the equal sign, and like that's why we had to do like the slice to get rid of the equals.
Mm-hmm.
What's a alternative way?
Oh, and I'll make a mix in my sports metaphors. Forgive me. But when we get to this calculate response, we don't want the thing that we're calculating to have to know about this like other hanky shit. So really what we want to do is just not have added the equal sign. It doesn't hurt us too much with the C since we immediately clear it, but we don't want that equal sign to get in there at all. And really, we don't want it with this one either. So what we could do is turn this into an else if, and this into an else. Maybe do something like that. So now it's only going to get appended to the screen if it's not a C or an equal sign. Ooh, interesting. And now my guess is that we can probably get rid of that slice and everything still works the same. Let's see if I'm right. 2 plus 2 equals 4. Pew, pew. Minus 2 times 9 divided by 8. Cleans up the logic of that a lot. Other questions?
What would this have looked like if you try to do like a dot get on your event target as opposed to the appending of text content?
If you were doing a event target dot get like that.
Yeah, to kind of retrieve the user input, and then I guess you would want to append that, or you'd start running through the following logic, the logic right below it.
So you already have the dot get. You might be mixing up the form thing. This isn't form data. And so we can just get the text content directly. We don't need to do a dot get or anything for it.
Got it. Yeah, I'm definitely mixing up the two.
Yeah, we can just pull the whatever is currently in that input directly out of the text content. I'm not wild about the word calculator string here, and I'll tell you why. So we call that Hungarian notation because the guy who came up with this idea at Microsoft in the early 90s was Hungarian or had a Hungarian sounding name or something like that. It's probably not awesome. But the idea of appending something's type to its name, that's Hungarian notation. We generally don't want to do that. So why? Why don't I want to put the type as part of the name?
The type could change.
Type could change. It's a let. I can reassign it. Uh-oh. You're just making yourself a future liar. So let's think of a better name that we could use than calculator string. Do you really want to describe what something is, like in the terms of the problem domain, not the technical domain?
It's an expression as well. So could you just call it like math expression? Or?
Sure. A input expression. I like that. Could have gone with calculator input also. I don't hate that. But cool. So now we're describing what it is. Next thing, if you're doing an if-else chain like this, where you're comparing different values at the same time, that's a special kind of if-else. Do we know what it's called?
Could we use a switch?
Yeah, that's a switch. So we can, instead of, let's do it this way. So I can turn this into switch case and say, all right, in case it's C, then I want you to clear the value, quit looking for matches. Otherwise, if it's an equals, I want you to calculate the response and then break. Otherwise, I want you to do that. Those two things are the exact same thing. Or I guess that's the same thing.
So the C is just what's on the other side of the equal sign. So you're saying each of these cases is like its own little if statement?
Yep.
Okay.
It's saying, when I evaluate this, if it's C, do this. If it evaluates to equals, do this. If it's none of those, do this.
Cool.
And anytime you find yourself just comparing the value of the same thing to a bunch of different things, that's a switch. Because let's say we upgrade the calculator in the future. It's got a bunch of fucking science buttons and shit now. That's how we would add a button. Super flexible. All right, so we've improved that. Other questions about the switch statement? Make sure it still works. Should. Oh.
I think it's your variable. You switched it from calculate string.
Oop. Thank you. All right, back in business. Cool, still works. Other questions about switches? All right, who's ready to have their mind blown?
Woo!
Let's go.
That's the kind of enthusiasm I'm looking for. All right, so I'm also not crazy about switch statements. If statements, switch statements, any kind of conditional logic. I don't fucking care for it. In fact, I gave an entire talk not so very long ago about how much I hate conditional logic. And it was called Programming Without Ifs. God, that was 2 years ago. That feels like yesterday. So the problem with ifs, and you may have heard me mention this at a stand down at one point or another. Is cyclomatic complexity. That's your like crazy ass vocab word for the day. Cyclomatic complexity has to do with how many independent paths through the code there are. So when this function runs, it can go through the C, it can go through the equals, or it can go through the default case. So there's 3 completely independent paths inside of this function. So if I'm testing this, I need to test all 3 of those paths. This gets out of control really quickly. Let's say I was doing that thing like with the scientific calculator, I'm adding all these extra buttons to it. Every single one of those increases the complexity of the function in a very bad way. They're also brittle. There's these things in switch statements called fall throughs, where if you do that, I'm actually not all that clear what would happen, because it's going to hit this. It might also hit the default case. It doesn't have to be precise matches too. You can do like regex and stuff in these. So it could hit more than one case. Ooh. You can do all that stuff very unintentionally. And you can also make it very order dependent in a way that isn't clear. Like in this case, this versus this doesn't make any difference, but that's not the case with everything. Especially if you're using fall throughs. Ooh. So, oh no, Kyle, what do we do about this? Well, there's a pattern. This is one of the most advanced patterns you will learn in the entire program, and you're here for it. The thing we're going to do is called a dictionary lookup. Basically, we turn logic into data. So instead of looking at which of these things match which response, we instead make an object that maps this as a key to some kind of behavior that it should have. So we could call this operation. Oh, actually, I'm going to skip to the harder one because I think I have to with this. We're going to call this one's called actually called dynamic dispatch. Principle's the same though. We're going to make an object, and now instead of looking up these cases, we look up keys in the object. So we'll have one for equals, for example. We'll have one for C. And then we'll also make one for default. So the syntax on that looks weird. It's just an object. I'm just assigning functions to the values. Could have just been that. Oops, come on. Just an object with some keys and values. But if I look something up on there, like that, that'll give me back a function that matches whatever the thing I looked up was. Same thing with C.
So you look up a key and it returns its value.
Exactly. That one could have also been that, by the way. Remember, we can look up things with dots or we can look it up with braces. They're the same thing, except with braces, we can also put variables in, which is cool. Questions so far about this?
So, man, this is complicated. So starting in line 16 here, as Jason said, you look up a key, returns the function. So line 16 would return calculate response. Let's imagine your object contained like 20 different functions. Would you have to key in 20 different operations with the bracket notation as you did in line 16 through 20?
No, we're going to show how we can look that up and dynamically dispatch something in a sec. All we're doing right now is getting the functions back. But no, you don't have to individually key in each one.
Got it.
Tiffany, I see the wheels turning.
In line 20,
Yeah.
you have default and a string.
Yep.
Why do you need a string for default there when you didn't set it to a string in your object?
Ooh, I did. All object keys are always strings. Even though I didn't put them around this one, that and that are the exact same thing. You have to put it in strings if it has goofy characters, if it has spaces, if it has like a variety of other things. So putting the quotes around it is a little bit more flexible, but ultimately these are the same thing. And what would this be? That's something very different. What am I asking for in line 21?
Are you just asking for the key and not its value?
What is default there?
Are you making it default instead of calling it on default?
I'll tell you what, if I ran this, the error that I would get would be unknown variable default.
So is it thinking of it as a variable, but the default variable hasn't been defined?
Ding, 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 ding. That's the entire power of bracket notation with objects, is that we can put variables in them. You can't do that with the dots. If I do dot default, it's going to look up a key called default. If I do this, it's going to take whatever the value of the default variable is and look that up.
So with line 23, would you get back clear value?
Yep, I would get back whatever the value of this is. I get back this function. Now, if I made that operations lookup input expression, now I'm going to get back whatever the thing that matches the thing that I put in was. Oh, interesting.
So there you get back a function?
Yeah. If the input expression is C, and I look up the value of C on operations, it's exactly like if I did this. I'm going to get back that function. So I could call that operation. Ooh, but what if it's 2? What do I want to happen if it's not equals or C?
Default.
I want it to be default. So I could say, if the thing that comes back from that is falsy, I can look up operations default. So if I look up 2 on here, what do I get back? What's operations at 2?
Nothing?
Yep, undefined. So it's going to use this or here and go, or look up the default. The default's just a string too. Could have called that fart. Works the same way. Okay, so I have that operation back. And now, moment of truth. So I have looked up a behavior dynamically, and now I can dispatch it. It's a function. You can invoke functions. Fucking sick. So now, let me do any of this. Now I can move that stuff from my switch statement over here. So like I could make this calculate response. I could make this one clear value. I can make the default. Default gets a little bit trickier. So I'm gonna actually open up the function body there, just paste this in. Cool. I wonder if it works. Holy shit.
So what's this called again? The const operations?
Dynamic dispatch.
Can you go straight to it?
Yep.
And sorry, and how come you don't invoke it? Like in the switch, you invoked calculate response, but here you're
So
not.
what is calculate response? What is like this thing that I set this equal to?
A function?
A function definition.
Mm.
That's what I want. I want to be able to dynamically look up a function definition so that I can invoke it. Be patient with yourself on this one. This is the most complicated programming pattern that we teach in the entire program.
Kyle, I'm still a little uncertain on why we needed to do the OR for default. The reason why I'm uncertain is because I thought that default would also be included in your input expression in line 9.
So so like where we're using default is for things like 1, 2, 3, 4, 5. So if input expression is 4, and I try to look up operations at 4, like that, nothing comes back from that. Remember, default isn't magical. I could have called it Kyle. It's just some string. There's no like default behavior of an object. So this is how we simulate that with that OR statement. It's
So now
not,
how is that different from your input expression there, like before the OR?
so another way to put it, it's not like the default in switch. Default in switch is like a magical switch behavior that comes with JavaScript. What we're doing here, default is just some string. So if I press 4 on the calculator, input expression becomes 4. All right, and I have these. And what's cool is that these don't even need to be in this function anymore. They're just data, so I can move them out. Oop, except now with input expression. Take it back, never mind. Forget I said that. All right, so I grab this input expression, it's 4. And then let's say that the way that this line ends up working becomes that, because input expression is 4. So I'm saying, all right, look up operations 4. And it goes, cool. I got an equals, I got a C, I got a string called default. I don't have a 4. And so it goes, all right, well, that becomes then that. It goes, all right, well, undefined is falsy. What about this? All right, if I look up whatever the value of default is, I get back a function. Functions are truthy. So the assignment goes through. Then operation ends up being that. And since that's a function, I can invoke it. Does your head hurt yet?
Mm-hmm.
So I press in a number. It tries to look up that operation. It can't find it. So instead, it looks up whatever the default is. The value of every single one of these is a function definition. I have a function definition. I can invoke it. So then I enter the plus symbol. And over here, this becomes operations. All right, look up plus. It goes, I got an equal, I got a C, I got the string default, I don't have a plus. So that becomes undefined. So we get the default behavior, which just adds it to the screen. So I've got 4 plus. The 4 works exactly the same as it did before. So now I have 4 plus 4 on the screen. I hit equals. Oops. So this becomes this. Come on. So then that becomes that. He goes, all right, you want an equals? I have an equals, actually. So then operation becomes calculate response. Cool. So then I can invoke calculate response. It's a function. And so it calculates the response. Then I want to clear it. So I press the C button. It goes, all right, let's try looking up C. And it goes, all right, I got an equals, I got a C, actually. So then the operation becomes clear value. That is just clear value invoked. Ta-da! And just to be fucking precious about it, I can get rid of all that. I can get rid of all that. I can put this in parentheses. So that will result in whatever function comes back from that. And then just invoke that directly. Put that in your pipe and smoke it. Does it work? Oops, nope. Can't access operations before. Oh, maybe I can't do that in parentheses. All right, hoisted on my own petard. Yeah, it's trying to do this like right at the beginning. Shoot. All right, never mind. You'd have to do it in 2 steps. Oh man, I really want to get this object out of here though. Wait a minute now. Coulda, woulda, shoulda. This thing needs an input expression. Well, I can pull that out through closure up here, or I could pass it in as an argument. But however will I get that into there? Oh, you mean like this? And now, finally, I can put that in a different file for all this thing gives a shit. I have taken logic and turned it into data. Oh man, one more piece of gnarliness. So this thing takes this as an input and then immediately passes it into another function. Anytime you see that shape, this is like cross cancellation when you're like multiplying fractions or dividing fractions or whatever. If I'm just taking something in and then immediately passing it to something else, what I'm really doing is just calling screen append. So why be clever about it? Screen.append is a function definition. That's a function execution. That evaluates to whatever that returns. That's just the definition of it. This is like a big aha moment for Mod 3. because functions in JavaScript are fundamentally different than methods were in Ruby. We call this first-class functions. A first-class function is just a variable you can use like anything else. You can save a string in a variable. You can save a Boolean in a variable. You can also save a function in a variable. Ruby doesn't have an equivalent idea. Closest is blocks, but even that's not really the same thing. We can just pass functions around as arguments. We can return them from functions. We can save them as values of these little hashes here. And then use them in super flexible ways. There's something I didn't like about that.
Was it just because you had a trailing comma, or?
No, I don't think it was that. I think it's because we're using append, which is strictly speaking not the correct way to do this. Really what you want to do, append is for DOM elements. Your browser is pretty friendly about what it will count as a DOM element, but really what this should be is something like text content plus equals would be the correct way to do it. Works the same way. But yeah, append is technically looking for a DOM element. I can at least make it on one line. Other questions? One last thing. Since we're passing in this input expression, we're not using it in this one or this one, but it's still getting passed it. Well, wait a minute. If I have input expression, isn't that really the same thing that I'm doing there? I think it is. Hot shit. Still work? Yep. Somebody didn't like. On calculate response on line 30, expected an expression and got equals. Oh, I see why. Because it didn't take in the entire, it's just passing in the most recent character. I see. Never mind, take it back. So let's review. Go all the way back to the beginning. All right, so here's where we started. We talked about staying consistent on query selector. We talked about staying consistent on single quotes versus double quotes. We talked about how, like, all of this, we had that really awkward thing with the slice. that we can get rid of if we turn this into ifs and elses instead. Because really we just have 3 different paths that we want there. And we talked about how we can get rid of, so if we have those ifs and elses where we're looking at a single value the whole time, we can turn that into a switch. We talked about we can get rid of switches with dynamic dispatch. We talked about first class functions. Ended with that. Questions?
So one of the last things on the README is about the errors. Would we, if we want to like do the divide by error or divide by 0 error, would that just be another key value in our operations?
So that's something that you want to catch in the calculation. Let's see what happens if we do divide by 0 right now. So we get infinity. So what we can do is, rather than trying to like pull it out from like the tokens, which we could do also, we're like, all right, any division symbol where there's a token after that that evaluates to 0, don't do it. But with this, we get infinity. All right, well, now we can say something like, if result equals infinity, I think is like, I want to say that's a keyword, and no, it's a string. So we evaled it. Text content. So we could do that, or we could do something like give an error message. Oh, we can get rid of the clear value if we just make it an equals instead of a plus equals. Dope. There you go. And anytime you see this pattern where we're setting something equal in like 2 branches of a conditional, you might know this one. Anybody know what our awesome refactoring opportunity is?
Like a ternary?
And we got it. So we could say something like screen.textContent equals that. If that's true, or its result. Still work? Ta-da. God, JavaScript's fucking awesome. Cool. Last questions before we break. All right, go ice your head.
Thank you.